Okay, so the hardness is the key. So, you raised the point before. So firstly, we've got hardness. The second point is that if this is very hard, and it's wearing against this, what's going to happen to that?
Well, that's going to disappear.
Correct.
Wear away.
Correct. So when we first released the injectors about 5 years ago, we always had DLC in mind. It just took us the first 2 years to work it out. So the reality is that we could put them into the marketplace, we could code them up, they'd be great, they'd run 20,000 Ks and they'd slowly divide and move away. And what was happening was that these were changing significantly over the time, and we ended up with that.
In a sense, with the DLC coating, was this wearing faster than the combined without?
Significantly.
Yeah.
Because of the hardness.
Because of the hardness.
Correct. So, whilst it's definitely harder than where it was, and it's not as hard as the test, it is around that tungsten carbide level.
So, are you now got DLC coating inside the nozzle? Is that where you're getting?
No.
No. Okay,
So,
we've done something else.
Right. So, and this is where we end up with one of the keys to the process was we ended up having to invest a significant amount of money in order to buy a CNC honing machine. So the advantage of, we had to buy basically the world's most accurate honing machine and the only one that we could find available to do what we wanted to do. And what we ended up settling on was basically a 2-stage honing process. So what we do is we will get the bore and we will do this and get an RA of roughly 0.4.
Yep. So for those who've just joined us, RA is effectively a unit of measure that measures the peaks and lows on a surface and it averages it out.
Yep.
Did I get it right? I'm learning.
Now, this value here, we're talking 4 10,000ths of a millimetre. So we're talking stupidly finite. We make it look good on the picture, but the reality is you've got no chance of seeing that with your eye.
Okay. Yes.
So we start off with that process. What we found was, if we honed it with RA01, which is remarkably complicated to do in its own right, but if you could hone it to that accuracy, they would last really well. Okay. The problem that we had was they'd get too hot because there's no lubrication. Right. So, if we did this, they were lubricated really well, they never got too hot, but they didn't last.
Yes.
The solution was a combination of both.
Somewhere between these.
Correct. So, the honing machine that we had to buy was the world's most accurate because it had to do 2 things. Firstly, we had to get bore cylindricity ridiculously straight.
Get so parallel.
Parallel and exactly round. Yes. So our bore roundness, if you look at the hole and then you look at a perfect circle, again, I'm as good as drawing as you are.
I think you're better.
you get a roundness average, which is kind of like roughness. Now, anything sort of less than 0.25, 0.3 of a micron is pretty remarkable. We can get our roundness to 0.02 of a micron. So that would be a millimetre there, and that's our roundness.
Okay, so it's stupidly round.
It's stupidly round. Now, over the whole bore, we're 40 millimetres or so.
Yes.
Which 40 millimetres in this context is an acre.
Yes.
We can get the total bore cylindricity to about 2.2 of a micron. Absolute minimum to maximum. So it's pretty damn awesome. So, first thing it had to do was to do that. The second thing it had to do is if we did a run of 1,000 injector bodies and did a 2-stage process, we have to completely reset the machine, stick a different arbor in it, go through the entire 1,000 again, and have that midpoint accuracy of how far it's boring out exactly the same on every single one, or within 0.1 or 0.2 of a micron. So, what we're doing, on a 0.4, we've probably got total 1 micron. Well, it's around the wrong way. We've got total of 1 micron from absolute minimum to absolute maximum. So we rough out to a certain size. Yep. Then when we do our finishing, we finish to 0.6. So we take out an additional 0.6, but with the stupidly accurate and stupidly fine RA01.
Yep.
So what this is called plateau honing. So it does 2 things. Firstly, it provides us with a very flat, very smooth surface in order to distribute the load.
Yep, of that.
The wear.
Onto that DLC coating.
Correct.
Yes.
But it also provides us with the Baileys for lubrication.
Wow.
Now, as far as I'm aware, we're one of very few companies in the world that do plateau honing using stones. There's people that use like a filament, like a flexible thing that they put down there, almost like on the end of a drill or a wire
But
brush.
you need the stone simply for that parallel axis.
Absolutely, because we need that surface finish to be so ridiculously parallel and cylindrical that we couldn't use a random setup.